So how would we write the ratio of girls to boys in our class? How would we write that as a fraction? How would we write girls to boys as a fraction? May, help me out. 14 over 11, like a fraction. How do you read it? How do you read? If you were reading that as a ratio, how do you read it? 14 to 11. And then how else could I write that? Samuel? 14 over 11. That's already been given. Then 14 to 11. And then there's one more way that you can write a ratio. Who knows the next way, Brock? 14 colon 11, just like we see. Now, where have you seen a colon before? Where have you seen a colon used in math, Tyler? On time, when we're talking about hours to minutes. Now, looking at this, notice the first one said number of boys to the number of girls in our class. Then we have number of girls to the number of boys in our class. Do you think, with ratios, let's have a conversation about this. Do you think order matters? Is order important? Yes. Have a conversation at your tables and think about what does a ratio do, and is order important? So two things. What do ratios do? And is order important? Because we need to come up with a working definition for ratios. So take 2 minutes and discuss. What is our task?
To talk about how
Okay, what is our task? We got two things that we're supposed to be doing. Okay.
To discuss if order is important and what ratios do.
What are ratios? What do they do? And is order important? So have a conversation. How much time do you have? 2 minutes. What do you think the ratio
Okay. I think the bigger number. What does it do? I was thinking.
Okay.
Earlier in the thing, Jesus
What's the ratio?
The shape. It's like for everyone.
What's the ratio do? All right, let's come back together, please. And so I would like for this group, I would like for you to share with us the definition that you all came up with for ratio. So Taylor, share with us your definition. What is a ratio doing?
It's comparing a number to a number.
It's comparing a number to a number. Does everybody kind of agree with that? Anybody disagree with that? We're comparing a number to a number. Any other thoughts? Samuel? He says it's a fancy math multiplication problem. Do we agree with that? No? Yes?
So let's say you have two pineapples. For every two pineapples you buy, you get one normal apple. So you buy 4 pineapples, you get 2 apples. The ratio of pineapples to apples is 2 pineapples to 1 apple.
Pineapple, apple.
That makes sense.
Okay. She says that doesn't make sense. Does anybody want to elaborate on Samuel saying that ratios are fancy multiplication problems? Go, Taylor.
If you had 13 to 14, 13 times 2 is 26, and 14 times 2 is 28. They don't work. They're two different numbers that can't be multiplied into each other.
But they're not the same. So you're saying that Samuel's wrong.
He is wrong, because if I took 2 to 3, it wouldn't work, because 2 times 2 is 4.
And 3 times 2 is?
6. So it wouldn't work. They're always going to be 2 apart.
Okay. So she's saying they're always going to be 2 apart. She said that 2 to 3 is not the same. 2 to 3 is not the same as 4 to 6. Why?
Because,
They're not the same. Or are you saying because they're not the same numbers?
yeah, they're not the same numbers. And you won't always have, say, like 1 to 2 that can multiply into each other.
But would you say that 2/3 is the same as 4/6?
Yes.
So why is that not the same? Would you say that 2/3? She said that 2/3 is the same as 4/6, but 2 to 3 is not the same as 4 to 6.
I didn't look at it as a fraction. I just looked at it with the multiplier.
So what do you think it's the
I
same?
do think they're the same now that you put the fraction part into it.
So is what Samuel's saying that ratios are kind of fancy multiplication problems? Do we think he might be onto something? Maybe? Some of you are still like, I'm definitely not saying yes, he's right. I'm saying, yeah, I don't know yet. We've got some thoughts. All right, so let's hold on to these thoughts as we continue working. So we say that ratio does what? Everybody, what does a ratio do? Compares two numbers. Did you all came up with that, right? All right, now, what else is going on with the order? Does order matter? All right, and Kate, what was your thoughts? What did you share with us?
Order matters because if you were to write your numbers backwards, then you could have the completely wrong answer.
If you wrote it a different way, she's saying it would come up with a different answer. Do we agree with that?
Yes.
Does anybody want to argue differently? Okay, you do have an objection? No?
No.
Okay, all right. So what we're saying is that we're going to have this working definition that you guys are going to come up with, the formal definition. And already you say a ratio is comparing two numbers. We're comparing two things, and we're good here. And you all said, everybody has agreed then that order matters. Okay, so we're good there. All right, we're going to continue this idea of this precise ratio language, and we're going to continue with our notations and being able to that's going to be ongoing throughout this whole entire unit. All right, what questions might you have? Now let's go on to the next side since there's no questions.
Ready?
Yes, dear.
That light shining off your dress. If I shake my head, I see red, green, and blue.